Hello, good morning. Welcome to Thursday. So when I left uni, I kind of had this idea that being a data scientist meant I was going to sit in front of a computer and tune models all day, right? Like I'd have these well-defined problems, I'd have nice data sets, and my job was basically to be effectively a professional Kaggle competitor. It turns out I was wrong, and we've learned a bunch of things over the last few years shipping data products to Zendesk. We've shipped quite a few, and we've grown the team a fair bit. And I think this talk is going to kind of cover some of the things that we've learned along the way. I think shipping data product is very much more than just building models. Models are an important part of this, but they're also just a small part of what it takes to get an idea that's going to be powered by machine learning out in front of customers, engaged with, and actually being used. So I will also give a caveat that I'm giving this talk, but it actually represents the work of many amazing people who are not me and who are not here today. So I'm just kind of the messenger in this case. So first things first, let me give some context. I'm Chris. I manage the data science team at Zendesk. I've been there for about 5 years. I guess linking back to Miguel's talk yesterday, we run sort of a hybrid model, so we're centralized and embedded at the same time, partly because we're geographically distributed. So we're in Copenhagen, San Francisco, and in Melbourne. So we get all of the time zones, which is incredibly fun and challenging, but it's also really cool to be able to engage with so many different parts of the business. If you don't know what a Zendesk is, basically we build a family of products that help organizations to understand their customers, improve communication, and offer support when and where it's needed. And support is kind of historically our core business, but we've branched out quite a bit beyond that more recently. So at Zendesk, I think we really believe that we capture really interesting data sets. We have an amazing view of how companies interact with their customers across the world. And we also really believe that we can use this information to build better product and build better customer experiences. So just a bit more context setting, I'm just going to walk you through briefly 3 products we've built over the past years that have been powered by machine learning, because they're going to come up throughout the talk. So the first one is AnswerBot. AnswerBot at a high level is basically, its idea is to allow people submitting support requests to self-solve their questions. So you send in a request, we use machine learning to match that against knowledge base articles that the company has, and give you the ability to close out the ticket without an agent having to be involved. And this is really useful for the end user, for the submitter, because they don't have to wait in queue, for an agent to get to the request, which sometimes can be days. They get an answer immediately. But it's also great for the agents because they don't have to answer the same questions over and over again, and they can spend their time helping customers who really need that more hands-on experience. Another product that we've shipped recently, earlier this year, is called Content Queues. And the idea behind Content Queues is to give context to content creators. So in our guide product, which is our knowledge-based product, people write help center articles, and the question is, where should I spend my time? Where should I focus? What articles should I write? So Content Queues basically takes all of the support tickets that your company's getting. We cluster them together, we generate summarizations for that, and we can surface that information up to the content creators so that they can create better and more targeted articles and think about where they should be spending their time. And the final product I want to talk about briefly is called Satisfaction Prediction. This is the first machine learning product we shipped. The idea here basically is to predict whether or not a support experience is going to end up with a good or a bad outcome before that actually happens. And then you can use those scores. It's kind of like a sentiment analysis, but slightly fancier than that. But basically you can use those scores to drive business automation to engage with support cases that look like they're turning bad before they actually close out, and so you can do something to sort of turn them around. So there are 3 products that we've built over the last couple of years. And I'm going to talk about a couple of areas I think that I've sort of that weren't obvious to me when I started out as a data scientist, that became really important parts of building these products. I'm going to talk about how data product is still building product, the importance of investing in infrastructure, the importance of being able to learn as a team, why scaling is hard always, and why user experience is a super important and probably underrated part of actually building machine learning powered product. So data product is still product. I think one thing that wasn't obvious to me coming out of university is why everyone wouldn't just want to use machine learning for all the things all the time, right? And then you turn up in a company and you realize that a company has a huge amount of priorities, right? And there's all of these places you could apply machine learning, but doing machine learning just for machine learning's sake is not going to be enough to get buy-in to actually make that happen, to build data product, to build a data products team. So you really need, to get organizational buy-in, to get on a product roadmap, and to actually get prioritized against all of the other really important things that a company needs to do, you need to be able to sell why you think the thing that you want to build, this data product, is going to be really valuable. And it's particularly challenging for machine learning because machine learning also brings with it like a high level of uncertainty, right? You start out on a machine learning project and you don't know in advance whether you're going to be able to build a model that's going to be successful for the problem you're trying to solve, right? It's research, so it's unknown. If it wasn't, it wouldn't be as fun and interesting, but it also makes it a harder selling point. So I think the way we think about this and the way we get around it is to speak to the business the way that everyone else speaks to the business about product. So we treat building data product just like any other product. And there's kind of three things that we think about in this, like three main takeaways, I think. One is to start with the customer, and I think this is key to building any consumer-facing product, right? What are the problems they're facing, and what do you think it is that you can do that's actually going to help them? What's the value you're going to provide? And you want to be really clear about what that impact is and why it's going to be valuable. Once you have a good understanding of what that means, you should really start digging into your data and think about how can I frame a hypothesis around this? How would I test this? How do I measure success? What does the metric look like? And then do I have the data to actually answer those questions? Because if you don't, you need to start getting that data. And once you've done well to frame this problem of what it is you're trying to impact and how you're going to measure your impact, then it's kind of get into the agile side of things, be iterative, iterate, and start moving towards that. And I think with data product, there's all these fancy algorithms you can use, but you really want to start simple. It is amazing and depressing how often a heuristic or a simple tree and if-then-else statement will actually help get you a long way to solving a problem that looks really hard from the outset, right? And as a machine learning research person, that's kind of depressing, but from a product delivery perspective, it's amazing because if-then-else statements are substantially less complex than building a neural net. And so I think once you go down that path, I think the advantage of having sort of thought about what your customer value is and how you're going to measure success is that when you start with your heuristic, your simple thing, and you notice that it doesn't work as well as you need for the product, right? You've got this really clear value proposition around why you might want to use machine learning to start closing that gap. So you're measuring this thing and we need to get this metric from here to here, but the heuristic only gets us halfway, so we need to do something more to make this viable. And that puts you in a position that's much easier to sell the investment into machine learning. So some takeaways on thinking about product that I think about. You want to be really clear about how you're going to measure success. You want to work with your product manager if you're lucky enough to have one, and always sort of come back to your customer value. And I think this is something that we've found to be really successful, both in sort of communicating and getting buy-in for the ideas that we have around how we can use machine learning to impact our product, but also in scrapping a whole bunch of ideas we had around how we could use machine learning to impact our product. Because you go through this process and you realize this cool thing over here where I have lots of data, where it's a really interesting ML product, when we play it out, actually the impact on the customer is not going to be amazing. So let's do something else. Let's spend our time better. Investing in data infrastructure. Again, coming from research background, doing a PhD, you're often the person who is in command of all of the things. You get to pull your own data sets. You do all of the data wrangling. You do all of the stuff, right? And so, again, it wasn't obvious to me moving into industry afterwards that this kind of had to change to actually make data products scalable and robust and something that you can ship and put in front of people. A data product requires infrastructure, and it requires infrastructure that is often different to the infrastructure that the rest of the business has. Data lakes, clearly you need your data from somewhere. Also, ability to serve your machine learning models in production. All of these things are really important. And I think a thing that we've sort of learned over the last few years is a great way to get investment for this stuff is to tie it to customer value, right? Tie it to something that the business wants to see. So for us, a good example of this was 5 years ago. We started a data team, right? And a data team needs data. So we started looking into how we would actually get data to start building data product. And we realized that the thing that had made Zendesk successful at scaling horizontally to our fast-growing customer base was a thing that was really in our way as a data products team. So this fancy picture here basically gives you an overview of what our data architecture looks like in production. And without going into detail, effectively, the way we scale horizontally is to shard our databases. So we can just keep adding more and more database shards as we get more and more customers. And this is amazingly useful and efficient for scaling for more and more companies using Zendesk, but it's terrible from a data analysis and a data product perspective because there's no single place to go to get all of your data. And so for us, the first thing that we had to build as a team was not machine learning product, was not like some fancy thing. It was actually go and build a data lake so we could get our data, so we could set ourselves up for success. We really needed to get that in order to make it work. And I guess like back in the day, this was 5 years ago when we started building it, our approach to building a data lake was all bare metal, it was Hadoop, it had closure in it, it was pull-based, so we'd reach out to all of these shards every single day and pull in all of the changes that had happened to build up snapshots of what the world looked like. Luckily, I think we've moved forward from that these days. We're in AWS, it's all a push-based system. We use this really cool service called Maxwell. If you're interested, you should go and check it out, it's open source by us. And basically the idea behind Maxwell is it listens to the binary logs of a MySQL server. And every time a change happens in a MySQL database, it's written out into the binary logs. It's like the history of all the stuff that's happened to the database. Maxwell basically slurps that up and throws it into Kafka topics for you so that you can then, from our perspective, from a data lake perspective, we have EMR jobs that run in AWS that read from those Kafka topics, roll that all back up into sort of the state of the world, right? So we now have this single place where we can go and query all of the data across all of our database shards in one place using things like Spark SQL or Athena, which is sort of our tools of choice at the moment. So this was a really big engineering investment, right? Like the first iteration of our data lake and the second iteration of our data lake, there's a lot of engineering work that goes into that, and there was not really much machine learning work that goes into that. But we had to make that happen to build up our data products team. And the way that we got buy-in to that was to build something together with this that the company really cared about from a product perspective. And in this case, it was what you see on the screen here. It's called benchmarks. And basically the premise here is it gives a support organization the ability to compare how they operate, what their metrics are for their support organization, so customer satisfaction, full resolution time, first reply time, all of these things to industry standards across other companies using Zendesk. And so I kind of think of benchmarks as the Trojan horse that got us to be able to build ML products, right? So benchmarks got us a data lake. After that, we built satisfaction prediction, and as a byproduct of that, we got the ability to serve machine learning models in production. After that, we built AnswerBot, and we got the ability to do natural language understanding and serve neural nets in production. And so we've kind of framed all of our infrastructure investments around investing in products that the company cares about. And it doesn't always have to be something fancy. I think some of the things that came after this had a lot more ML in it and were a bit fancier, but benchmarks is super straightforward, I think, from a mathematical perspective, right? There's basic aggregate statistics happening here, but the customer value was enough that it was worth the investment, and it got us a data lake, and that was pretty awesome. So I think two takeaways. One is, obviously, you need data infrastructure, and you should be investing in that. The other is that your infrastructure investments, a great way to get buy-in from that for your company, if you're finding that hard, is to tie it to a customer, something that provides customer value. And it doesn't have to be anything fancy. But yeah, getting that buy-in is going to make the whole process and getting resourcing a lot easier. Water break. Okay. Learning to learn. I think this is like, if there's one takeaway from all of these things, this is the one, right? Like, I think it's a recurring theme in everything that we've ever done, and it's probably a recurring theme in your daily lives. And most people who come into the data science space know how to teach themselves stuff. It's kind of it's a weird sort of collection of people from all sorts of different backgrounds, right? But I think I'd argue like the number one skill for a data scientist and for a data science team is being able to learn new things. And it's because the research is moving so fast, like the state of the art in the field, both from a research perspective, but also a tooling perspective is constantly changing. And if you can't get good at learning not just individually but together as a team and upskilling each other, that's going to be a real big challenge for you sort of as you go out and try and build what can be quite complex and challenging data products. So a great example of this for us was building AnswerBot. So AnswerBot at a high level kind of does this, right? You send in a support request like you see on the left here. It was originally designed to respond to emails. So someone writes in an email asking sort of a question about some problem they're having. And we want to build some sort of fancy machine learning to match that to a knowledge base article that exists. And this doesn't necessarily sound hard because it's kind of like search, but it's a bit harder than search because in this case, the thing that they're asking about is dumping out ticket data, but that's kind of buried in this really long form email, right? So throwing it into Elasticsearch or something like this is just going to fail miserably. So it's a very similar premise, but there's a whole bunch of ML you need to do to actually make this possible. And at the time when we were building this, we started with classical ML, and there's a few reasons for that. One is I'm a big believer in do the simplest thing first and see if it fails. The other is that deep learning hadn't really gained a lot of traction in the NLP space at that point in time. So kind of the baseline back then was do TF-IDF and throw it into an SVM or a logistic regression. And it kind of worked, right? We had a lot of labeled data. But as we started down this path, we started learning very quickly that we were running into challenges. Some of them were we didn't have an even spread of data. So for a particular customer, maybe they have 100 knowledge base articles. We would only have, say, 10 articles that had a good number of example tickets that mapped to that article, right? So a good number of labeled examples, and the other 90 articles didn't have much data. So we didn't really know how to learn a model for that. Cold start problem is a huge thing when you're building product for consumers, right? And you're using supervised learning. If you don't know what the cold start problem is, it's basically you get a new customer, you don't have any data for them, so you don't know how to build a model, right? And there's some lag in time between when someone starts with you and when you can actually make the product successful for them. In our case, there's two ways that happens. One is it's a completely new customer to Zendesk. The other is it's an existing customer to Zendesk who maybe has changed an existing knowledge base article or created a new article where we now need to wait some period of time before we have enough data to make that work. All of those things don't make for a great customer experience. And so we spent a few months going down this path, both from the research perspective and from the engineering side, so how we would actually build this and get it into production and put it in front of customers. And we basically hit a dead end. From the research side of things, we realized we could not make these models work well enough to make the product sort of a good value proposition. So we had to pivot, hence where the learning comes in. And we threw away a lot of work, right? And we had to start fresh as a team, and we had to upskill as a team. None of us really had a background in neural nets. None of us really had a background in NLP. And it was really hard. We had to go and read a lot of things. We had to together learn how to use a bunch of new frameworks and sort of start driving a research agenda that we didn't really understand. And it was hard, and there was about 1 billion times where we thought we were going to fail miserably. And then like all good research, it's like failing. Ooh, it works. And we were happy. And I think, from a technical perspective, we ended up with rolling our own fast text embeddings, passing that through LSTMs and some fully connected layers, and we end up with basically the ability to embed both the tickets that come in and also the articles that might answer them, and the idea is that the tickets and the answering article are close together, so we can just do distance-based metrics. And that was quite nice, and it becomes a nice solution for the product because we end up with one global model that can serve all of our customers. We get away from the cold start problem because we have a global model. We don't need training data for your new customer. And that actually made the product a lot more viable than it would have been from a supervised learning perspective. But none of that would have been possible if we weren't able to learn as a team. And so I have some thoughts about ways to make learning part of your culture. I think the first one, and it's a really important point, is creating a safe space. Learning new things means having new ideas, right? And it also means being wrong a lot. And a team really needs an environment where they can bounce ideas off each other, where they can interject, where they can collaborate. And that's only going to happen if they feel like they have emotional safety, right? If they feel like they're not going to be called out or chastised for having a wrong idea or a poor idea, right? That's like research doesn't work like that. There's 1 billion poor ideas, and then there's a good one, and people only remember the good one. But you really need an environment to enable that. And I think without that, you don't have a research team. You have a bunch of researchers sitting next to each other. And I don't think that's going to get you to being able to solve the hard problems that come up in front of you. The second point, I think, is around running a journal club or a paper club, right? This is something we've done since the inception of the team. Every week we get together and we talk about a particular paper that we've seen in research, or maybe we spend a few weeks deep diving into a theme like reinforcement learning or natural language understanding. Building that muscle on how to learn was something that was really important for us, and it helped us a huge amount when we got to this point where we had to learn a whole bunch of new things, and now our product kind of depended on it, right? And the final one, I think, is try and get your research as far ahead of engineering as possible. We had to pivot and throw away a bunch of research, but our engineers also had to throw away a bunch of infrastructure that they had written to support that research, right? And so it's kind of it was doubly impactful from the amount of wasted work. I think pivoting is really important, right? And it's kind of a given if you're doing research. You're going to run into things that just don't work and have to try new things. The further you can get out in front of engineering and sort of reduce that uncertainty by the time you need to build the infrastructure that's going to support that, I think the better from a product delivery perspective. Scaling is hard. Taking an idea that works for one customer and making it work for lots of customers is hard. It's hard if you're doing an app, it's hard if you're doing machine learning, it's hard if you're doing basically anything, right? in my mind, I think when it comes to data product, there's kind of two categories of scaling. One is the build more things approach. This is kind of like, you need to build a model per account for some particular machine learning problem. So you need to take an approach to building a model and you need to just maybe build thousands of them instead of one of them. And the other is make a single model do more things. So that's kind of like AnswerBot, right? We needed to make a single model work for all of our customers. And so it's challenging from a research perspective, but not so much from an infrastructure and scaling perspective. On the side of building more things, two examples of that for us are satisfaction prediction and content queues. Both of those products require us to build a model per account. And we have more than 145,000 companies that pay to use Zendesk. So you can imagine there's a lot of model building that goes on there, right? I think there's a few things that, like a few key points in making that work. One is you need to automate the data scientists out of the loop. There is no way you can employ enough data scientists to go and hand tune 145,000 models, right? And even if you could actually find all of those people, you certainly couldn't afford to pay them. So you need to be able to come up with a way of actually tuning those models and validating that they're good enough and shipping them to production that doesn't involve a human actually looking at them. And the other thing is that the runtime performance and memory usage of those models is going to become super important, right? Because if you build one model and it takes 5 hours to build, okay, that's fine, but you multiply that by 100,000 and that's a realistically large amount of time that you probably don't want to pay for compute for, right? So I think like those two things are really important things to think about when you're trying to scale your model building. The other thing is that you need to invest in some infrastructure to actually make this happen. Back in the day, we had to do all sorts of weird things to make Hadoop do this for us. Luckily, these days, we're happy users of AWS Batch, which is amazing for this sort of thing. You can queue up your jobs, it goes and does the compute for you and writes all of the output to S3. It's very nice. There's a really good series of blog posts if you're interested a little bit more in how we use AWS Batch to build and serve machine learning models. Just go and search for AWS Batch Zendesk machine learning. You'll find it, and it dives into a lot more technical detail about how this works. From the make one model do more things side, I think this is a less obvious approach to scaling, but it's definitely something that comes up a lot. Something that came up again in AnswerBot. I said before that we built this one global model for AnswerBot, and that was amazing. We didn't have to build a model per account. Well, actually, what we built was one global model for all of our customers in English. And it turns out we support a lot more languages than English. And so we didn't really have a global model, and we were back to trying to work out how to actually build more models again. The way we approach this at the moment in production is literally to build more machine learning models. So a ticket comes in, we do some sort of language detection, and based on the detection of the language, we route it to the particular neural net model that we need to do the embedding. But this only scales so far, right? Because we don't necessarily have enough data in some of those languages to be able to train a model of the complexity that we use for English and Spanish and Portuguese, right? So we start running into some constraints around how far we can actually go in supporting the long tail of languages that people use in Zendesk. Recently, we've been experimenting a lot using Muse embeddings. If you haven't heard of them, they're pre-trained embeddings that come out of Facebook. Historically, we didn't have much luck with pre-trained embeddings, and we kind of had to roll our own. Muse seems to work really well for us, actually, at least so far. We're kind of in the testing phase at the moment. But I think the really interesting thing that Muse provides is that the embeddings are aligned between languages, right? So like the word for dog is embedded to exactly this, give or take the same space in English as it is in German, as it is in French, as it is in Portuguese or Japanese. And that's super useful because we can actually use that to just build up one big dictionary of like all the words in the world and train a single neural net to be able to do AnswerBot for us instead of having multiples. And that seems to work quite okay. But there's still two trade-offs on that. Like one is that you need to build a really big dictionary and you need to host that in memory, and that is painful sometimes. And the other is that we still run into another challenge for AnswerBot, which is called out of vocabulary. So a lot of companies have products that have weird names, and they don't tend to turn up in dictionaries of the English language. And if they're not in the dictionary, we don't know how to embed them, so we don't know what to do with them. So a path that we're starting down now is looking at building single character models that don't have a dictionary and trying to build those for multiple languages. We're very much at the beginning of that. If any of you work in that space, please come and talk to me in office hours. I would love to pick your brain. Yeah. I think takeaways from scaling, getting from one to many customers is hard, always, fact. Scaling needs tooling, and you should really think about the investment of that up front. And global models are great. If you can build a global model and you don't have to build 100,000 individual models, you should do that. And sometimes it's worth the trade-off you might have in performance. So, you're always giving up something to build a global model. But if you're also saving yourself 6 months of engineering investment to get a product out the door, that's not necessarily a bad trade-off. All right, the last thing I wanted to talk about was user experience for the win. I think this is overlooked a lot. But the user experience is really where the rubber hits the road for your machine learning model, right? It's how people engage with your models, and you can build the best model in the world that predicts all things perfectly. If no one looks at it and no one does anything with it, no one cares, right? We learned this with AnswerBot. When we first built our neural net models for AnswerBot, we wanted to start getting validation from real people around how well they were performing. And so our first pass at this was to build what's called a sidebar app in Zendesk. You can see an example of one here with answers suggested. And the idea was that an agent would be on a support ticket, and we would be suggesting articles on the right-hand side, and hopefully they would give us feedback about whether those articles were good or bad. So it turns out the thing that we missed there, like amazing implementation, very nice and neat, right? Like you could totally interact with that and see what it does. The thing that we miss from a user experience perspective is that agents have really well-defined workflows, and asking them to change their workflow to look at a new piece of information is actually something that is really hard, right? They've got KPIs around how they need to do their support performance, how quickly they need to answer tickets. They get into a flow, and asking them to do something different to what they were doing before requires a lot of convincing. Additionally, most Zendesk instances don't look like that with a single app on the side, but you're competing for space against a bunch of other useful apps that are part of their workflows already. And so what ended up happening with this is we shipped it to production and no one engaged with it because it was different to what they needed to be using in support. And so we got no feedback on our models, which was poor because that's what we wanted to do this for. We kind of got around that by going and hand labeling a whole bunch of data ourselves. It was a good stopgap in the short term, but I think we really missed the UX optimization there. Later, once we got confident with that, we started putting the models out in front of people. And so this is what the AnswerBot experience looks like now. You get a customer question, we suggest some answers, and you get this button that says, yes, close my request, right? And when we put that out in front of people, the idea is, the more often people click yes, close my request, the better the model is, and we can use this to actually work out how good we're doing at suggesting the right article. But when we first shipped this, we didn't say, yes, close my request. We had a button that said, solve my request. And people clicked on that a lot when we put AnswerBot out at first. And we thought that actually meant that our models were doing amazingly. And then we got suspicious because it was doing really, really well. And then when we dug into it, it turned out that we had different expectations around what that button actually meant. From our perspective, it was, we've suggested the article to you, you found the right answer to your problem, and you're clicking this button because you want to close your ticket and tell us that we've done well. From the end user perspective, what they thought that button meant was, I click that button and someone reaches out to me and they're gonna help me solve my question, right? So we had a mismatch in what we thought that button meant, and the wording was really important because we ended up measuring something that was not what we thought it was. We got no real feedback on what our model was actually doing. So my takeaways on the UX side is, it doesn't matter how good your model is, if no one engages with it, nobody cares. You need to be really conscious of making your interactions with machine learning models clear, because you're relying on that feedback, and if the people giving the feedback are giving you feedback that doesn't match with what you're expecting that feedback to mean, you're not actually learning anything, and it can be really dangerous because it can send you in completely the wrong direction. And the last one is kind of like a thing from my side of things. I personally believe machine learning should never get in the way. If you're building a machine learning product, machine learning is never right 100% of the time. So you really want to be able to build the user experience in a way that when it is right, you're providing value, and when it's not right, you're not getting in the way of the end user or slowing them down. Okay, so that was like a journey through a bunch of stuff that we've done over like the last 5 years. I think hopefully you agree with me that there is a lot more to building data product than just building models. Certainly this is kind of like a note to my old self from graduating uni days, that there is a lot more involved in this, and there's a lot more people involved in making it actually go. I think hopefully some of those lessons are useful things and you can get some takeaways from those. I'm happy to talk about any of this and more in the office hours. This is my thank you slide. You'll notice in the small text on the side it says we're hiring. You can ask me about that too. Cheers.